Hello, I'm OurSync, creator of WorldFabric, a game engine that automatically provides top-of-the-line real-time networking to arbitrary C++ code. I talked in my last devlog about the underlying algorithm, relativistic synchronization, which makes it possible to get a smooth experience with thousands of interactable objects without writing game-specific networking logic. There's a link to that in the description if you're interested, but all you need to know for this video is that it works. Today I'll be talking about the interface for WorldFabric and what I mean when I say automatic networking. I conceived of WorldFabric around the time Facebook changed their name to Meta. I love the idea of a metaverse, but like everyone else, hated what Meta was making. I was playing Zenith: The Last City and Rumble VR around that time, which gave me a glimpse of what virtual reality could be, but also both suffer from poor networking and slow production. I want a version of the metaverse that makes creating experiences like those quick and easy, and the networking needs to just work. I also want it to be like the open web of the 90s and early 2000s, where the hardest problems are already solved, but there's no one charging rent or dictating how things have to be. Virtual reality has fallen out of fashion for now, but it turns out infrastructure for the metaverse is really good for online indie games in general. The first online game using the WorldFabric app engine is called Narball, and you can play an early build on itch.io right now. Narball is a great candidate for WorldFabric because it needs high-quality networking to be fun, but it's too small to justify building it. Its simplicity also makes it great for illustrative purposes, so let's get into it. When I say WorldFabric provides automatic networking, what I mean is that it takes raw C++ classes and functions you write and generates new code around them that hooks into the world system to keep multiple copies of a running application in sync. It automatically generates serializers for your objects, wraps your event calls so they get transmitted, and handles rollback and time warp for you. As long as your code follows the rules of the app engine, you can write it without considering networking and it will just work. Not everything should be in the app engine though. It's really only for core game logic that needs to be in sync. The main rule for code running in a world event is that you can't access anything outside of the world, so you want to keep things like file loading, rendering, and UI outside of the app engine. The boundary between the synchronized code in a world and the rest of your app requires some special care, but that's for another video. Let's take a look at an example world object from Narball. When you first create a server, the world contains a single object, the lobby. Overriding world object tells the engine you intend to put these in a world. World objects come with an ID set by the engine and a vec3 position set by you that the engine uses for time warp. Beyond that, it's whatever data you put on your object, but there are some rules. You can't use pointers in world objects. If you want to reference another world object, you can use its ID like a pointer and call the built-in read function when running events, which will enforce the speed of light delay. If you want to reference data that is not another world object, well, you can't. Information from outside the world has to come in through events and their parameters. The final rule for world object data is you can't use any unsorted or non-deterministic data structures. Functions used for world events have a similar set of rules. They have to be void functions. The parameters have to be const reference. Yes, even small raw data types. It makes the generated code simpler. No pointers, no references to outside objects, and no non-deterministic or unordered structures in the parameters either. Here's the code for adding a player to a lobby. It's just normal C++ code. When a player joins a lobby, they cue this event to add themselves to the game. The only WorldFabric specific thing here is the use of the time keyword. The first rule of world events is they are not allowed to read data outside the world, which includes the system time. If you want to do something based on time, use the world time, which is always available as just time when you're inside an event. The second rule is you can't do anything non-deterministic. There's a built-in pseudo-random number generator you can use, though. The third rule is that code inside an event function can only modify the object it is running on. When you read another world object, you'll get a const. And if you want to change another object, then you do so by queuing a new event on that object that makes the change. You can call functions on the same object as much as you want though, and you can call functions on objects you read as long as they're const. Here's some more code from the lobby. Clients are expected to queue events to keep their connections alive every half second or so, and the server will periodically queue an event to remove players that haven't checked in for too long. Remove player is itself an event function, but you could also call non-event functions as long as everything done during the course of your event obeys the data indeterminism rules. Here's a snippet from the ball update function. If you want an object to move in real time inside a world, you can do so by having an event re-queue itself after each run. The queue function takes as parameters the ID for the object the event is to run on, the time it wants to run, though it could get delayed by the engine, the function to call, and any parameters required for that function, which are not present in this case since update has no parameters. Here you can also see an example of the read function in use. Narball has a match world object with told references to the collision detection grid as well as several general parameters like the tick interval, used for updates across the entire game. Read returns a pointer to a const of a specific world object, but it also has the potential to return nothing or an old object, so it's important to cast dynamically and check that you got what you expected before moving on. Since reads have a speed of light delay due to relativistic synchronization, sometimes you get a null pointer for an object that does exist, because the information about its creation hasn't had time to reach the event that's attempting to read it yet. That's something to keep in mind. One last thing to note here is another important world fabric keyword, destroyed. If an event sets the destroyed flag to true, the object it is running on will get deleted when the function exits. It's the only way to delete things in a world, since world objects can only be modified by an event running on them. Now you might be wondering, what happens if I put objects or functions into world fabric that violate the rules? Well, if you violate the data rules, you'll get a compile error that'll tell you the offending object. That's easy enough to handle. But let's say you let some non-determinism slip through or accidentally read a changing global variable from inside a world event. In that case, you'll get a desync between players after that code runs. Unfortunately, World Fabric cannot detect desyncs at runtime. World Fabric manipulates the flow of time to hide latency and improve performance, and it doesn't actually keep players in sync under normal operation. When players are close to each other, the system will put in the work to keep them synchronized, but as they get further apart, they're allowed to diverge more. Keeping players in sync involves rolling back and rerunning events, which is computationally expensive and is also what creates the familiar lag artifacts of objects teleporting or sliding. These rules are what make selective rollback possible, which is the secret sauce that makes relativistic synchronization feel so good and runs so fast. The trade-off is that you can't detect someone as desynced until about a half a second after it has happened. But debugging desyncs is still possible. There's a special logging mode that can log every event in game time order to a CSV file, and there's a desync finder tool to compare logs from multiple players after the fact and tell you exactly what function caused a desync, when it was called, on what, and what the parameters were. The logs can get big fast though, making the tool a bit cumbersome to use, but I wouldn't have been able to get Narball working without it. I had hoped to get more into the collision detection and how it's possible to build complex systems on this simple backbone, but I think I'll save that for another video as this is getting pretty long. I hope this gave you a clearer picture of what World Fabric actually is and why I'm so excited about it. I don't think it's ever been this easy to build online games that work so well. I plan to release the entire World Fabric and Narball source code when it's ready, and the final version of Narball will be available for free on Steam as well. If you want to chat about the tech or participate in a Narball playtest, there's a World Fabric Discord link in the description. Till next time, our sync out.